Hello everyone, welcome to the another session of Big Data tutorial series, and in today's session we'll be talking about Zookeeper and HBase. My name is Rajan Chhetri. I am the instructor for this crash course, and today I'll be sharing my experience and knowledge about Zookeeper and HBase. So let us understand what we'll be covering in today's session. In today's session, we'll be talking about Zookeeper. What exactly is Zookeeper? What role is played by Zookeeper in a distributed system? What are the various components of a Zookeeper architecture? We'll be talking about HBase, what is the difference in HBase and HDFS, and we'll be talking about the HBase architecture. We'll be having a lab on HBase as well, in which we'll be exploring how HBase works. So first of all, let us start with what is Zookeeper. In order to understand Zookeeper, let us talk about distributed systems first of all. Now, in a distributed systems, as we already know, there are hundreds of computers which are working together. Multiple software components are working on multiple computers, and they are running as a single system. Now, these computers can be physically close or they can be geographically distant. Now, the goal of the distributed computing is to make such a network work as a single system. Distributed systems offer many benefits over centralized systems. There are many benefits. I would discuss few of them. So the very first benefit is scalability. We can horizontally scale distributed systems in order to improve the performance of overall cluster and in order to reduce the response time of any application which is running currently. The second benefit of distributed system is basically the redundancy. Now, several machines can provide the same services, so if one is unavailable, work does not stop. Smaller machines can be used, redundancy not prohibitively expensive. Now, Hadoop can be a very good example of distributed computing. But when we involve distributed computing, there are various challenges which comes along in the architecture or in a distributed architecture. Now, I would say the very first challenge that you're going to face in a distributed architecture is of coordination. So you can think of multiple machines working together, but they need coordination, in order to get the work done without any deadlock or a barrier. That's where Zookeeper exactly shines. So what exactly is Zookeeper? Zookeeper, it's an open source Apache project. Now it provides a centralized service for providing various services. Now it provides us services like coordination. It provides us services like configuration, management, I would say, naming services, synchronization among group of services over a large clusters in a distributed system. Now the goal of Zookeeper is to make these systems easier to manage with improved and more reliable propagation of changes. Now how exactly Zookeeper works basically? Let us suppose if you have a Hadoop cluster spanning across 500 or more commodity servers, you would need centralized management of the entire cluster in terms of naming, grouping, and synchronization services. You would also be requiring configuration management and distributed synchronization. Now, one approach to solve these challenges is to write your own system from scratch to manage the coordination and configuration management. But what if I tell you that there is already a system, a stable system, I would say, which is already available with us, and it's a proven system for coordination and configuration or synchronization management. So Zookeeper provides an infrastructure for cross-node synchronization by maintaining status type information in memory on Zookeeper servers. A Zookeeper server keeps a copy of the state of the entire system and persists this information in local log files. Now, the other benefit of Zookeeper is that the large Hadoop clusters are actually supported by the Zookeeper servers. Now, let us talk about the various use cases of Zookeeper. Zookeeper is used for various purposes. As I told you earlier, it's a coordination service. Apart from being a coordination service, it also provides you with configuration management and cluster management. So what does that mean basically? It means that you can use Zookeeper for for enabling the configuration of all the nodes which are working in the same cluster and managing the configuration of all the nodes. Apart from that, it is also used for naming services. So for example, let's say if a node wants to find another node among the thousands of servers, we can do it easily using the naming services provided by Zookeeper. It also provides us, distributed synchronization. It helps in preventing the locks, barriers, or it also helps us in creating the queues of the request. Now there is a concept called leader election in the Zookeeper. Now what does that mean basically? Now similar to Hadoop, Zookeeper also works in master-slave architecture. Now the difference is that in Zookeeper we have multiple masters. Now why is it so basically? Now, now the introduction of multiple masters in Zookeeper is to bring fault-tolerant feature. Now when we have multiple masters in a Zookeeper cluster, so only one node acts as a master or as a leader. So if there is any master which is not available for many reasons, so there is something called leader election, which is a process of identifying a new leader among many Zookeeper servers. Zookeeper also provides you a key value store. Basically, you could call it a you can call it a data registry, which is used for storing the data, which will be available across all the data nodes. All the Zookeeper services are distributed, they are reliable, they are fast, and they are simple to use. Let us understand Zookeeper more in detail by looking at the architecture here. Now this architecture consists of various components here and it follows a sequence of execution. In the next few minutes, we will describe each component one by one. So how Zookeeper works basically? Now Zookeeper follows a client-server architecture. All systems store of the copy of the data. So it means basically if any data which is prepared or generated will be copied across all the servers. Now there is a leader among all the servers which is elected at the startup. Now what these components are basically, let us understand these components one by one. What is a server? The server sends an acknowledge when any client connects. In the case when there is no response from the connected server, the client automatically redirects the message to the another server. Client. So client is one of the nodes in the distributed application cluster. It helps you to access information from the server. Every client sends a message to the server at regular intervals that help the server to know that the client is alive, and we call it heartbeat. Leader. One of the servers is designated a leader. It gives all the information to the clients as well as the acknowledgement that the server is alive. It would perform automatic recovery if any of the connected nodes fail, let's say. Now there is something called ensemble. So group of Zookeeper servers which is called ensemble or a cluster. You can use a Zookeeper infrastructure in the cluster mode to have the system at the optimal value when you're running the cluster. Now that was the introduction to the components basically. But let us understand exactly how the Zookeeper works. So here, the first thing that happens as soon as the ensemble, which I mentioned earlier, which is a group of Zookeeper servers, starts, it waits for the clients to connect to the servers. After that, the client in the Zookeeper ensemble will connect to one of the nodes. That node can be any of a leader node or a follower node. Once the client is connected to a particular node, the node assigns a session ID to identify that particular node. And once it is connected, it sends an acknowledgement to the particular client saying that the request has been accepted. Let us say if the client does not get any acknowledgement from the node, then it resends the message to other node in the Zookeeper ensemble and tries to connect with it. So, on receiving the acknowledgement from the client, make sure that the client connection is not losing by sending the heartbeats to the node at a regular intervals, which is generally 3 seconds. Now, finally, the client can perform functions like read, write, or store the data as per the need in a Zookeeper cluster. So that was basically, the execution or the workflow of a Zookeeper service. As a summary, I would like to brief it out in a very simple way. So the client tries to connect to the server to perform read-write operations. In case if the server is not acknowledging the request, then the client tries to connect to the other server. If the other server accepts the request, it sends an acknowledgement to the client. Client, on a regular interval of 3 seconds, keeps on sending a signal to the server specifying that the client is alive, and that signal is basically called heartbeat. Once the server has acknowledged the request, the client can perform the read write operations on the server. Let us try to understand the Zookeeper structure, or you can say the hierarchy of the Zookeeper nodes. Let us learn what happens when the client has been confirmed to perform the read-write operations on the server. Now, whenever a client basically connects with a server, the client tries to read and write some data from the server. Now, how the server knows basically which client is performing the operations or which client is requesting for the read-write operations, and that is because of a data model. The structure that you can see here is basically the data model, which is similar to the file system. Now here, these are called Z nodes or Z nodes basically. Now Z nodes specify the clients which are connected to the Zookeeper server. Now whenever multiple Z nodes or multiple clients are trying to perform certain operations on the server, they coordinate through this shared hierarchical namespace. It looks like a Unix and Linux file system. So here, this Zookeeper data model follows a hierarchical namespace as you can see here. Now here, each node is called a Z node basically. A node is a system where the cluster runs. Every Z node has the data. It may have a children or it may not have a children. Now these are called Z node path basically. Now these Z node path are always canonical. These are slash separated and are always absolute. They do not use any relative references, and these names are allowed to have Unicode characters. Now these Z nodes are of various types. So these Z nodes can be categorized into 3 different types. One is persistence node, second is ephemeral nodes, and the third is sequential nodes. Let us try to understand what is a persistence node. So this type of Z node is alive even after the client which created that specific Z node is disconnected. By default, in Zookeeper, all nodes are persistent if it is not specified. The second node is ephemeral. This type of Zookeeper Z node are alive until the client is alive. Therefore, when the client gets a disconnect from the Zookeeper, it will also be deleted. Moreover, if we add one more, information about ephemeral nodes are not allowed to have any children. Now, the third type of node is basically sequential node. Sequential nodes can be either ephemeral or persistent. So when a new Z node is created as a sequential Z node, what we do basically we assign a unique 10-digit sequence to that Z node. So I hope you have clearly understood the Zookeeper data model and the various types of Z nodes. Let us understand what are the various roles played by Zookeeper in the Hadoop infrastructure. Now there are several components of Hadoop which uses Zookeeper for various purposes. For example, HBase, which is a NoSQL database in the Hadoop ecosystem, it uses Zookeeper for master election, server lease management, bootstrapping, or it uses it for coordination between the servers. Now, Hadoop and MapReduce use Zookeeper to make Resource Manager highly available or to bring the fault tolerance feature in the Hadoop cluster. Apart from that, Flume uses Zookeeper for configuration management purposes. Let us try to understand what are the various real-world use cases of Zookeeper. In order to explain the various use cases, I'm going to name some companies here. The very first company who is using Zookeeper is basically the Rackspace. Now, the email and the application team at Rackspace uses Zookeeper to coordinate sharding and responsibility changes in a distributed email client that pulls and indexes data for search Zookeeper. It also provides, various other services at Rackspace. For example, it also provides distributed locking. Twitter. Twitter uses Zookeeper for services discovery. Vast.com. Vast.com uses Zookeeper for sharding services. Yahoo. Yahoo is the major vendor of Hadoop, I would say here. Yahoo uses Zookeeper for various purposes and utilizes it most. For example, Yahoo uses Zookeeper for leader election, configuration management, sharding, locking, or group membership. The similar features are used by another corporation called Zynga. They also use Zookeeper for the same purposes such as configuration management, leader election, sharding, and many other features of Zookeeper are utilized by Zynga. So these are some of the companies who are using Zookeeper for various purposes and the features or the services provided by Zookeeper. I hope the use cases were clear of the Zookeeper. Now we had a introduction to the Zookeeper earlier, and I hope you have understood what exactly a Zookeeper is. Now let us start talking about HBase, which actually utilizes Zookeeper. Now, first of all, let us understand what HBase is. Now, HBase is a type of database. It is a kind of database, I would say here. So when we talk about databases, how can we forget RDBMS? So we'll start from RDBMS, we'll move to HDFS and then to HBase, which will make us clear about what HBase is and why do we need HBase. So first of all, let us talk about you know uh, RDBMS first of all. Now, if we talk about the history of the world, the world has been using RDBMSs for for their mainstay of the business. Now, millions of websites or web applications have been using RDBMS for many decades, I would say here. Now, there were some challenges with the RDBMS which were faced, in the mid of the you know 2000s, you can say, or in between somewhere 2003 and 2005. Now, what were the issues that were faced by the industria, when they were using RDBMS? The very first issue was scaling up. So when a data set is just too big to handle by the RDBMS, the scaling was a big major issue. The second challenge that the industry was facing was RDBMS was not designed to be distributed. Yes, it worked on a standalone system utilizing the power of a single machine, but the single system architecture or a standalone machine has their own limitations in terms of capacity, whether it is processing capacity or the storage capacity. Now, as a solution to scaling up or scaling out, people or professionals started looking for various different solutions. They began to look solutions such as multi-node database solutions. Now, in order to resolve these issues, different approaches were taken. For example, let's say the master-slave architecture is one of the solution for scaling RDBMS, and the second is sharding. Now, all the approaches, whether it is sharding or master slave, they have their own advantages and disadvantages. Now, apart from the size of data, the type of data was also growing. The type of data was also varying. That basically gave birth to a new form of data storage, and that is called NoSQL. Now, NoSQL stands for not only SQL. Now, it is a new class of data storage systems which gave birth to non-relational data. Now, the advantage of NoSQL is that it doesn't require fixed table schema, as it is required by a relational database system. NoSQL is more flexible, compared to the RDBMS systems. And NoSQL systems are more acceptable in the industry nowadays, and they are more adaptable as well. Now the reason behind the adoption of NoSQL is because of the various changes in the data. As I mentioned earlier, it is because of the size of the data, whether it is because of the type of data, or you can say it is because of the rate at which the data was growing, and to accommodate that size of data. Now, this data, the changes in this data happened because of the explosion of the social media sites with large data needs. Rise of the cloud-based solutions such as Amazon is another reason for the growing size of the data. Apart from that, the shift of the programming paradigm, from basic standard programming to the dynamically typed languages such as Ruby or Groovy are the reason for switching to the NoSQL type of databases. As a solution, initially, the very first solution which was provided by Google to the world was Bigtable. Bigtable is it's a NoSQL implementation of your databases. Apart from that, we have Dynamo from Amazon. Dynamo is among the other databases which are NoSQL based, and there are various other competent products available in the market. So in today's session, we are talking about HBase, which is inspired from Google's Bigtable. It possesses similar features of a NoSQL databases. So what exactly is HBase? So HBase is an open source distributed version. It is fault tolerant, it is scalable, it is column-oriented, uh, database with real-time read-write access to data. And as I said earlier, it is inspired by Google's Big Table. Now, HBase is column-oriented. It basically means that it uses, it uses column for accessing the data, and apart from the ordinary columns, we have something called column families in HBase, which is not there in the RDBMSs. So when should we use HBase basically, right? We should be using HBase when we need random real-time read-write access, to our big data. That's when we must be using HBase. Previously, we compared HBase with RDBMS, but here we're talking about HBase and HDFS. Let us try to understand what is the difference in HBase and HDFS. So first of all, let's talk about HDFS. Now, HDFS is a distributed file system. It is well suited for the storage of large files. If we talk about HDFS, it is a general purpose file system. It does so. The reasons behind HDFS, you can say non-performance, is that it does not provide fast individual record lookups. Yes, that's right. If we talk about HBase, on the other hand, it is built on top of HDFS, and it provides fast record lookups for larger tables. So why to choose HBase instead of HDFS? So the reasons for choosing HBase over HDFS is faster record lookups. HBase also provides support for record level insertions. It also provides support for updations. In order to deeply understand how HBase works, let us understand the HBase architecture. Now, HBase architecture is composed of three different types of servers in a master-slave type of architecture. So, what those servers are? HMaster, region servers, and Zookeeper server. These are three different servers of which HBase is composed of. Now, regions, right? These regions are managed by the region servers. They're responsible for DDL operations, I would say, such as creating, deleting operations on the table. Now, these operations are actually handled and are regulated by master. Region servers serve data for read and writes. When accessing data, clients communicate with HBase region servers directly. Now, this is Zookeeper, which is the part of HDFS, maintains a live cluster state. The Hadoop data nodes stores the data that the region server is managing. All HBase data is stored in the HDFS files. Let us talk about these components individually and in detail. So, master server or HMaster. Now, this HMaster is responsible for monitoring all region servers in the cluster and is the interface for all the metadata changes it runs on the server which hosts the name node. Master controls the critical functions such as region server failover and completing these region splits. The cluster can run on a the cluster can run without HMaster, and that's because of Zookeeper, because Zookeeper will take care of the HMaster failover. If there is an HMaster failover, the Zookeeper will help in electing the new HMaster. If we talk about the region servers are responsible for serving and managing regions. It is like a data node for HBase, I would say here. So region server serves the client request for the data. It handles the actual data storage and the request as well. So what it consists of? It consists of regions. You can think of regions as the tables. Now these region servers are generally configured to run on the servers of HDFS data nodes. Now there is one more benefit that these region servers provide, and that is data locality. I hope this makes all of you clear about the various components of Hbase architecture such as Hmaster, region server, region, Zookeeper, and the role played by them. Let us implement some of the commands of Hbase and let us try to understand how Hbase works and how to create and store and retrieve data in Hbase. In order to get started with the Hbase Lab, here I'm utilizing a Cloudera virtual machine here. Well, this is a virtual machine which is provided by Cloudera.com, and I'm using VMware Workstation here for running this virtual machine. In case if you do not have access to this VM, it is recommended to download this VM from Cloudera.com and the VM Workstation from VMware.com. So here, in this demonstration, first of all, we'll be opening the terminal, and here we'll be accessing the HBase services via a command line. And in order to access the HBase services, let's open the HBase shell. So for opening the HBase shell, we'll use a command here called HBase shell. Now HBase shell is the command to access HBase services. Once you press or hit enter, it will take you to the HBase prompt. So here we have entered into the HBase prompt, and this is the place where we'll be writing the HBase commands. Now in HBase, we get started with creating a table in HBase. Now generally the tables are slightly different compared to RDBMS. So first of all, let us understand the command for creating a table in HBase. The command is create. Create is a command for creating a table. The name of the table is students. So the name of the table can be anything. I'm using students here. And separate by comma. And here we will provide something called column family. So what exactly is the column family, we will understand in detail. Let us complete this practical first of all. So I would say personal underscore data and contact underscore data. So what these are column families. You can think of column families as a group of various other sub-columns, I would say here. So the term that I'm using here is sub-columns. So under one column family, there can be n number of columns. It is schema-less. We do not require any fixed schema to insert or save data in a HBase table. Let us hit enter. So here you can see that the table has been created. If you want to visualize this table, for that, let us open OneNote here, and we can think of that command as a table, and the name of that table is student. And here, basically, we have two column families with us. All right. So I would say here that's going to be personal underscore data and contact underscore data. So these are the two column families there. Now let us learn how to display the list of tables which are already existing. And to do that, we'll use a command here called list. So list is a command in HBase that we will use for listing the existing tables. So you can see here, I've got only one table here in my HBase, and that is students. So till now we know how to create a table in HBase, how to specify the column families, and how to list the existing tables in HBase. If you want to display the contents of a table, for that we have another command called scan. So we'll write scan students. Oops. So here you can see that it is saying there is an error here. It says undefined local variable called students. So this error is occurring because I have not included the table name in quotes. So let us resolve this error by including the table name in quotes here. So you can see here now it is working perfectly fine. So right now I don't have any rows, any columns or cells are not available in this table. It's a completely empty table. So let us learn how we can add a record in a table. In order to add a record in a table, we'll be using a command here called put. Now put is a command in HBase which is used to insert a record in a HBase table. Now please make sure that when you are inserting the when you're inserting the data in a HBase table, you follow the following sequence. So table name, record ID or row ID, column family, dot column name. And the value. Colon. So this is the syntax for inserting a record in a HBase table. So let us follow the following syntax. Put, the table name is students, record ID 1, column family, so personal underscore data, colon, column name, name, comma, value. So the value is going to be, let's say, Chris Hemsworth. And let us hit enter. You can see that it is not throwing any error and is working perfectly fine. Let us display the data of a table in order to know whether it is inserted or not. So for displaying the records of the table, we'll use the same command called scan. Scan students. So I think I included the codes in the scan, so that was invalid. Scan students, and here we can see the record. Now if you look at this construction, you will see that the column is, please observe the construction of the column here. The construction of the column is column plus cell. So here column family is the same as column, plus cell is name, and this is the timestamp which is automatically added by the HBase, and the value is Chris Hemsworth. Let us try to insert, and this is the row ID which we added. Let us try to insert one more record. So we'll follow the same command here. Put students column family contact underscore data colon column, that is mobile, and we forgot the record ID, that is 1, comma the value, and that is plus 91. All right, let us try. So we have inserted that record, and let us display the records once again. Scan students. If you look at this data once again, you can see here the record ID is 1, the column is contact data mobile, this is the column family, and this is the column name. This is a timestamp which is automatically added by the HBase, and the value is here. Similarly, we have personal data, column family, and the value is name. Timestamp is automatically added, and the value is Chris Hemsworth. Apart from that, we can do various things in HBase. For example, we can restrict a table to deliver the content, and we can do this by disabling the table. Let me show you how to disable a table here. So for disabling a table, disable students. Now the disable commands basically prevents or restricts the usage of the table. It disallows, or it basically cancels every command or request sent for that particular table. So let me show you a demonstration here. Let us try to display the contents of the students table by using the scan command. So if I do so, you can see here I'm getting lots and lots of log information here, and here the error says the students is disabled. So you can see here, simply by using the disable command, I can disable the students table or any table. To re-enable table, we will add other command called enable. This command is to enable the table so that we can retrieve the data from it, or we can read and write the data from it. So let us verify. Scan students. So here you can see that I'm able to scan the data once again. I'm able to retrieve the data once again. Let us learn how can we fetch a specific record out of millions of records. Let us say if I have millions of records, if I want to fetch only specific records, so how to filter the data. So this can be assumed as a where command in SQL. So how we do that? And for that, we'll use a command called get. Now get is a command which is used to filter the data based on a condition. So get the table name and the record ID or the row ID. So you can see here, get is a command which is used to filter the data. Now the syntax that it follows is get table name, row ID or record ID. So you can see here contact data, mobile, personal data, which is column family, and the name, and here are the values. Now we can also fetch a specific record and as well as a specific column as well. Now in the next demonstration, I'm going to show you how we can fetch a specific record along with a specific column. Let's try this one. Get students, the table name that is, and the record ID or the row ID, column, and that's the arrow symbol, personal underscore data, colon, name. So here you can see Chris Hemsworth. So how it is working basically? So get is the command for retrieving the data. Students is the table name from where we're retrieving the data. This is the row ID, and column is a keyword here. For this particular row ID, which column we want to fetch? For this column, I want to fetch the personal data column family and the name column from it. So here you can see that we have got the name column's value from the personal data column family. So that was the demonstration on HBase commands. So I hope you have understood the implementation of HBase and how to work with the HBase or the data in HBase. Now let us conclude the session by the summary here. HBase is inspired from Bigtable. It is an open source, NoSQL database. It has a good support from the community, and it supports automatic partitioning. It supports, batch processing as well as real-time processing. It is fault tolerant, and the best part is that it works on a commodity hardware. So that's all, folks. So if you have liked the explanation of this session, please do not forget to hit the like button, press the subscribe button, as well as press the bell icon for latest updates. Thank you very much for listening to me. I'll see you in my next session. Take care.